So, question 13 now. Looks confusing, doesn't it? These are all to do with surds and stuff, but let's see what we can do. So, we've got to sort all this out so it can be written in this simple form with root 10, where a is a whole number, an integer. I need to find a value of a. So, I'm just naturally what I want to do is multiply these things out. So remember, multiplication arm, times that and times that. So root 5, and this is something you need to remember, times root 8 is the same as root 5 times 8, which is root 40. So that's one thing you've got to remember. Similarly, therefore, root 5 times root 18 is going to be root 5 times 18. When you times by 5, double and half. Sorry, slow it, Simon. I'm going to times it by 10 and half that value. So that's 90, root 90 in the end. And so now I'm going to add these together because that's what it's asking us to do. So root 40 plus root 90. Now I have no idea where I'm going with all of this, but I'm just going to go with the flow. I see 10 there, and I can see a 4 tens and 9 tens, and that's really useful because that means that's going to be root 4 times 10, and that's plus root 9 times 10. And what's good about that is that's going to be root 4 root 10 plus root 9 root 10, and some of you might see this now. So that's 2 root 10 plus 3 root 10, and now, because they're common, I can add it together, so it's 5. So that's going to be 5 root 10, and they want a, so a is 5. Nice question. Okay, question 14. Now, y is inversely proportional, so, okay, you can write it like this as well. That's a fun symbol they use, which means it's y equals an unknown value, let's call it k over d squared. And often you have to find a value of k, and they'll give you a value. Oh, when d is 10, y is 4. Good. Y is 4, d is 10. 10 squared is 100 times 4 is 400, so k equals 400. So I'm going to write that out now, because I've got that, and I need to keep it there, boom. And then it says d is directly proportional to x squared. Okay, so d is directly proportional to x squared, so we write it that way, which basically means d equals something times x squared. I've got to find that something. I've got another k value here. It might be better to keep it as a different value. So yeah, I'm just going to do that. It doesn't really matter. I'll call it h if you want. And so now I'm going to find that constant. I've got values here of 2 and 24. So 2 squared is 4. 4 watts make 24. So you've got to think about that carefully, slow down. Half, half, 12, 6. So h here is 6. So I've got a new formula, d equals 6x squared. So I've got these two now. And it says, find a formula connecting y and x. Well, the only connector is this d. That's the only connection that I've got. So what I can do is I can make it go under there by squaring both this. So if I square that, I get 36x to the 4. So I've squared the 6 and squared that. Put it underneath, so y equals 400 all over 36x to the 4. But it wants it in its simplest form. So what I now need to do is I need just simply to simple down the 400 and the 36, and hopefully you can see that actually, I think, is it 4 that goes into it? I think 4 goes into 400 100 times, and 4 9s are there, and so that should be your answer. Good. Let's go for question 15. I hope we've got time to do that. We're 4 minutes 20. Yeah, we can do that. Right, so this is called factorising this. Now, you might not have a clue, but this is, again, memory. This is called a difference of squares. Difference of squares. And it's always going to be like this, where you have a, b, a, b. You can have that, but one will be a plus, one will be a minus. And when you multiply that out, you get a squared minus b squared, because these two cancel each other out. ab minus ab cancels out. So that's what you get. That's just memory. Hence, now that means from that, or if you know any other way, do another way. But I'm going to try and work it from that point. Simplify fully all of this. So here I've got, it really does look quite confusing, and it's going to take some time to think about. And essentially at this point, you've got to think to yourself, okay, you know, I'm just going to get bonus points here, but what can I do? Well, I see that A here, so I'm going to say A is effectively x squared plus 4, and B is effectively x squared minus 2, isn't it? And if I can do it that way, then suddenly things become a lot easier, because I can then put it into this form here. So I can say adding those two for that square, so that's x squared plus 4 plus x squared minus 2 gives us that first bracket. And then I can do here, I can say it's x squared plus 4 minus x squared minus 2. And just be careful of all the brackets and everything that goes on. You just have to be careful of the minuses. So on this side, I get 2x squared plus 2. And on this side, those x squareds cancel out, and I get 4 minus 2, so it's 4 plus 2 is 6. So now I can multiply everything by 6, and I get 12. Actually, let's do this first. So I get 12x squared plus 12, and I can take a factor of 12 out. So I take a factor of 12 out, and I'm left with x squared plus 1. Now, I agree, that's quite complicated. But what I did was I just said, well, look, the A is represented there, the B is represented there, and I know that that's how you do it. So if A equals this and B equals that, then I'm going to substitute into these ones here. Be careful with the minus. That's where a lot of people would have made a mistake, I imagine. Okay, quite a tough question.